All right, so this is Coach Stricker, and this is the bonding basics, okay? And so what we're going to look at, the first thing we're going to look at is the oxidation numbers. And you have to know oxidation numbers. You can't do bonding. It's kind of like doing algebra, but not knowing how to multiply, divide, or add, subtract. If you don't know the oxidation numbers, which are the charges that the elements make in order to become stable, because remember, everything wants to be like a noble gas, so these are the charges that these elements will make in these families every time in order to become stable. Because everything on the periodic table is neutral but not stable. So you need to understand that the alkaline metals is +1, the whole family. Alkaline earth metals is always +2s. The transition metals are always going to be positive, but they will vary in what they are, and we'll get into that later. Boron's family is +3. Carbon's family is plus or -4. Nitrogen's family is -3, oxygen's family is -2, then the halogens are -1s every time. So everything in the halogen family will form a -1. Now, it's important to understand that metals are also called cations, right? And the cat looks like, the T looks like a plus sign, so think about that. And they lose electrons in order to form positive ions. A lot of people have trouble with that concept because they think when you lose something, you're becoming negative. And I want you to look, if you have lithium and it has 3 protons and 3 electrons, if it loses an electron and now it has 2 electrons, then what is the net charge going to be? Well, 3 pluses and 2 minuses, lithium is going to be a +1 charge. And that's what all the metals will do. They will all lose electrons and form positive ions. Non-metals will gain electrons in order to form negative ions. So look at it as a negative ion. So you see that word anion, it's a negative ion, and they will gain electrons in order to form negative ions. So if you look at like fluorine has 9 protons and 9 electrons. If it gains 1 electron and now it has 10 electrons, it has 9 pluses, 10 minuses, so the charge is going to be -1. All right, so that's why the halogens all form -1 ions. All right, so that is like one of the main things that you have to understand is the oxidation numbers, because when you're doing bonding, you're going to see later that you have to cancel these things out. All right, so then we get to the 3 types of bonding. There's ionic bonding, there's covalent bonding, and there's metallic bonding. All right, now we'll start with ionic, and we're going to spend 2 days on ionic, so it's going to be a lot. But ionic bonding is always between a metal and a non-metal. All right, and so it involves a transfer of electrons. Well, what does that mean to transfer electrons? If I say I'm going to transfer my pen to Denise, what am I doing? I'm giving her my pen, okay? So I give up the pen, and what does she have to do? She needs to take it. So what you're going to see is in this bonding, one of the things gives up electrons, and that is the metals. The other takes electrons, and that is the non-metals. So the metals are giving up electrons, the non-metals are taking electrons. And that's why you get pluses and minuses. Now, when you form a plus and a minus, the total charge has to cancel out. And we'll talk about that in a minute. All right? Covalent bonding is between 2 non-metals. So 2 things to the right of the staircase. Ionic bonding is going to have 1 metal, something to the left of the staircase, combined with something to the right of the staircase. Covalent bonding, 2 or more things that are to the right of the staircase. So all the non-metals are over here. And they share electrons. And you're going to see there's a thing called the law of multiple ratios, which means you can form a bunch of different types of ratios. So you could have like N2O5, you could have N3O6, you could have N7O9. Okay? And that's the law of multiple ratios. And you're going to see that they can form more than one way. That is the opposite of ionic. Ionic is the law of definite proportions, and they can only form one way. Okay, they can only form one way. So ionic, between metals and nonmetals, Transfer of electrons. Covalent, between two or more nonmetals, involves sharing electrons. And metallic is between two metals, and they call it a sea of electrons. And the electrons, like when the metals get together, like zinc and copper get together, there's just this sea of all these electrons. They're called delocalized, which means they come off of one metal, and they just kind of float around. And at any given time, there's 8 around zinc. And at any given time, there's 8 around copper. So it's just this big sea of electrons floating around, okay? And that makes for a lot of their properties. All right, so we're not going to talk anymore about covalent or metallic today, but I am going to go into a little bit more on ionic. So we're going to head over to this board over here.